Alright, in this video I just want to give a quick summary of which trig functions are even, which are odd, and what that means to us. So let's first begin with the even trig functions. And there are only two. Unfortunately, we like the even functions a lot, but cosine is an even trig function. Cosine is an even trig function, and therefore so is its reciprocal secant. Now what that means for us is that if I take the cosine of some negative value, let's say negative x, then that is equal to the cosine of the same x but positive. Okay, so it's like the negative just disappears. You can just disregard negative inputs to even functions. Okay, so similarly, the secant of some negative input, negative x let's say, is the same thing as the secant of positive x. And that's why we like the even trig functions, because the negative just goes away. And in fact, you don't have to have parentheses around the x then when the negative is no longer there. So you can see that in either case. Now the odd trig functions are all the others, the other four. So we've got sine and its reciprocal, cosecant. And we've got tangent and its reciprocal, cotangent. These are all odd. And so what that means is, if you take the sine of a negative input, well, you get the opposite of the sine of the positive input. Okay, so it's like the negative now doesn't disappear, but it's like it just jumps out to the front of the function, which is what some people assume happens naturally anyway. But it doesn't always happen, as you can tell from our even trig functions over here. Okay. Similarly, for the other four, the cosecant of negative x will be the opposite of the cosecant of positive x. The tangent of negative x will be the opposite of tangent of positive x. And finally, the cotangent of negative x equals the opposite of the cotangent of positive x. And so, again, all of the odd trig functions, the negative seems to come out of the input and is placed in front of the function as a coefficient, whereas the even trig functions, it's like it just goes away. Okay? So this can be useful when you're evaluating trig functions with negative inputs.